struggling to write SQL queries, spending hours fixing syntax errors and complex joins, what if you could type a question and get an instant answer with a perfect query?
As you can see here, the diagram is pretty self-explanatory. We have a question that we would like to ask about the information stored in our database. So here, LLM helps us to understand the requirements, generate the SQL query that will run the real SQL database, where the database will return the results that we can further analyze and answer our question. Before we start, just make sure that you have imported the required libraries. For this one, we will use the BigQuery as the database to pull the public data from. So for this, please install the pandas-gbq library. So once you install it, what you also need to do, you need to understand what's your project ID in the Google, right? In the Google Cloud. And it's pretty simple. You just need to log into your cloud and you will see the first project, or you can create your project. So once you define your project ID, then what you need to have to do is you can look into the public datasets, into the BigQuery by typing public datasets here. It will add the public datasets, and then you can scroll and find any databases you want that are free, and the public data is available to you for the analysis. So in this case, we'll use the Austin crime data. I would define the simple query where I would like to get the first 10 rows from this database and from this crime table, okay? And don't forget to insert your project ID, which is you can find on the Google Cloud. So once you load it, you can see that it's successful. The first time it may ask you to log in and validate the query. So you just need to confirm this using your Google sign-in option. Next step would be to define the query template that the LLM will use to generate the accurate SQL code. For this one, we can load the query template from the community. And if you want to know how the template looks like, what kind of instructions are present there, you can always go to the LangChain platform and see that yourself. So it relies on a couple of variables. The first one is dialect. That means the type of the syntax that will be used in the query. It can be the standard one, the MySQL or Postgres, for example. The top K results here defines the number of results, number of records that can be returned by default when the user doesn't specify the number of records. For example, when the user tells, please return me the employees, the names of employees from the database, then it will be limited by top K by default. The table info provides the context to the LLM understand how the columns are named and what are the types of these columns. And the input is basically our question to the LLM. We need to define our LLM, and for this one, I will use the chat-openai methods here that will help me to initiate the ChatGPT API model. So for this one, you would need to have the API key. The next step would be to define a couple of things that will help LLM to understand the context better and generate the more accurate SQL code. The first one would be to define a simple class that will help the LLM to minimize hallucinations and produce the valid SQL query code. As you can see here, we provide a little bit of context for the LLM to understand that we actually need the valid SQL query. Okay, and we also need to define the function to actually generate the SQL code. And in this function, as you can see, we provide the context for our table info, where we define the table name and the number of columns the table has. And then we would create our template and populate this with the variables that we defined before, right? As you remember, here we have four variables: the dialect, top K results, table info, and the user input, right? And then exactly what we're doing here. We populate dialect variable with the standard, top K with the 10, table info with the table info that I defined here previously, and the input will be our question. And then we would need to construct our structured input. So we need to wrap our prompt using the class that is called query output. As I said, is just to help the LM to minimize hallucinations. That's why we wrap it into the class. And once we define this, we can initiate and run our LM using invoke method and return the results. So that's basically it. Let's define it and let's do the test. For example, we can ask how many robberies were in 2020, 2014, and let's see what it does. And as you can see, the LM created the SQL code for us, and it seems like it's pretty accurate. It counts all of the records from the table where the primary type is robbery and the year is 2014. Okay, and let's run our code, right? And to do that, we can define the run query function that will just run and retrieve the results from the BigQuery table. Okay, we define our function, and now we can run the query that was generated by LLM and see how it works. Yeah, it actually returns us, as we define two functions, to write and run query, we can utilize the agent to do it automatically for us. So the agent will first generate the query for us, and then it will run it to return data from the database. And for this one, we would need to import the LangChain tools, because as the agent works, it relies on the number of tools to operate, right? So we would need to define this. We can keep our class as it is. We will use it as well for the agent. And we would also need to use our two functions that we defined before, but keep in mind that each function will serve as a tool for our agent, right? And for this one, we would need to define our first tool that will be writing the query, right? And here, what I did, I actually kept it quite similar to what we defined before, but I just gave it a little bit more context in the beginning. As you can see here, I kept the table info. I kept the same prompt template and the same generational result, right? So here we just return the wrapper result using the query output class, right? So I didn't do much here. As you can see, I just write the query given the user question and return it as the query output class, okay, as the valid SQL query, as you can see here. So this is our first tool. And the second tool will be to actually run the SQL code, right? So we just simply use the run query that we defined before here as a tool. Okay, so now we defined our two tools, and now we can combine them, right, into the single class. So we can say that the first tool will be the write query, and the second tool would be to run query. Now we define the tools. We can define our agent, and let's say we would ask the agent what are the top crimes in 2020, in 2015, and see what it does. So as you can see, it returned the results to us. The first tool it used is, see the name of the tool. The tool is the write query. Exactly, that's what we needed. And the second tool was to run the query. So it worked. It ran the two tools that we defined, and as you can see, it retrieved the numbers for us. Great. And as you can see, you can print the results perfectly. Yeah. But what we have specific terms for the crimes that the LLM may not understand. For example, if I ask LLM to retrieve me the number of snatches, number of purse snatches in 2016, the model is unlikely to return this. As you can see, the query that generated was completely wrong. I don't have the primary type as the purse snatch. It's completely off. And you can see here that it actually called the theft purse snatch. So how we can help the LM to better understand our specific categories of crimes? Well, we can define the simple rec approach here that will understand the categories that we have and remember them. For that one, we would need to import a couple of things. We would need to first import our embeddings, OpenAI embeddings, that will convert these categories into the numerical representation. And then it will be stored in our vector, in-memory vector store. As you can see here, we will add all the categories. What we can do next is we can define our retriever tool. So we can initialize the retriever. We can give it a little bit of description. And we can compile this and create our retriever tool for this specific case. And the idea of this tool would be to help the LLM to understand the specific crime categories when the user, for example, asks about the purse snatches or the homicide or the aggravated assault. The LLM will look up the values that we have and will return the right value for the SQL query. Once we defined our retriever tool, on the top, we can give it an extra context for the LLM to understand what this tool does and how it should be treated. And for this one, we can define it with the already known decorator add tool and the function that will search the proper nouns for the crime types. As you can see, I give it a little bit more context for them to understand that we actually need to look up the values for our SQL query and return the most relevant noun from the data set for filtering queries, okay? And as you can see here, I return the proper noun as the first one retrieved using the retriever get relevant documents query. So basically here, it looks up the values and based on the user query, it returns the closest one to the query, okay? That's exactly what this function does. So we define the function. Now we can compile our tools list. And we can also, as an extra step here, we would define the instructions that will work better for this use case. We would use the instructions for the agent now, and that's a little bit different. They only require us to specify the dialect and the top key. We don't need to specify the table information, something like that. The agent is intelligent enough to only work with the dialect and the top key results, okay? As you can see here, this is the instructions. You can always find it on the LangChain platform. So we define the instructions here. And we also added the suffix. So basically the suffix is just mention LM that it, or reminding the LM to utilize the search proper nouns tool whenever the user asks about specific crime types. So now we can initialize our agent again with the extra context that we provided here, right? So we can initialize it. and we can run and see how it works. So here I will ask the LLM how many snatches were in 2014, and this command basically shows me what's the logic behind the LLM, how it comes up with the answer. So you can see here, the first one was to look up the proper crime type. So it retrieved the theft per snatching, as the most accurate. And the second one would be to write query. So it did that. As you can see here, the query resulted correctly, and it was ran as well by LLM. So it performed 3 tools at the same time. The first one is the search proper nouns tool. The second one is the write query, and the third one is run query. And it done it in a logical, sequential way automatically. That's awesome. And that's what I like about agents, that they are intelligent enough to figure out which one to run first. Great. You can always run it in a simple way like that, where you will define, first of all, the config. The config is important for the LM to remember the conversation. So basically, each config has the ID, which lets the LM to remember and keep all the context in a specific conversation. And this is our question. And that's basically how we can run this and retrieve the ultimate result, the ultimate response from the query. As you can see here, it tells us that there was 7 thefts, incidents in 2014. Thanks for watching. Don't forget to subscribe and like, and see you soon.